In this lesson, we are going to talk about similar figures and similarity statements. Two geometric figures are similar if they have exactly the same shape, but are different sizes. There are two factors that contribute to this. First, all of the angles of one figure are congruent to the corresponding angles of the other figure, and all the corresponding side lengths are proportional. Here we have the similarity statement, triangle ABC is similar to triangle FEG. And there's a lot of information packed into that simple statement. Triangle ABC refers to the triangle with vertices A, B, and C in it. And triangle FEG is referencing the triangle with the vertices F, E, and G. Remember, in order for polygons to be similar to each other, the corresponding angles must be congruent to each other. The similarity statement will indicate which angles are congruent to each other just by their order. Since angle A is mentioned first in triangle ABC, and angle F is mentioned first in triangle FEG, we know that those two angles correspond with each other. And we also know, since they are similar, that those two angles are congruent to each other. Since angle B is mentioned second in the first part of the statement, triangle ABC, and angle E is mentioned second in the statement, triangle FEG, we know that those correspond with each other and are also congruent. And we know that angle C will be congruent to angle G because those are the third mentioned angle in each triangle ABC and triangle FEG. So the order that you write your triangles in your similarity statement has to be the order of the corresponding sides. We can also tell which sides are proportional to each other just by looking at our similarity statement. We see that AB is the first side and corresponds with this side right here, and that side corresponds with FE in the smaller triangle. FE is right here. And so we can write a proportion between those two side lengths. We can write AB is proportional to FE. Since B and C are the second and third vertices mentioned in that statement, and E and G are the second and third vertices mentioned in that statement, we know that BC will be proportional to EG. And finally, for the last side, you start with the first and the third letter, and you make that side AC, which in our diagram you can see is down here, will be proportional to FG, the first and third in that part of the similarity statement. And here we have listed all three pairs of corresponding angles being congruent to each other and the proportions between all three sides of each of the triangles. So here it is again in a slightly more cleaned up form. We have A is congruent to F because those are the first vertices mentioned in both of the triangles, and you can notice that they are also congruent to each other because of their markings on the diagram. You have B is congruent to E, the second in each of the triangle parts of the statement, and those each have two lines here and two lines here, so that makes sense. And then you have C is congruent to G. C has three lines, G has three lines. So all of those correspond with each other and are congruent. Then we have the three ratios. AB over FE means that this side is proportional to FE. BC over EG means that BC, this is the shortest side of this triangle, and it matches up with the shortest side in this triangle. And then AC over FG, AC is the longest side of this triangle and matches up with the longest side of this triangle. It is important to understand that all of these statements down here can be made by just looking at the similarity statement here. We actually don't need the diagrams at all in order to write each of these things. We can do it just by looking at what order all of the letters come in, and we can make all of those congruence statements and ratios. Similarity is not only a thing that affects triangles, it also can affect any polygon. Here we have two quadrilaterals, and we have the similarity statement quadrilateral HIJK is similar to quadrilateral NOPM. So if we break apart this similarity statement, we know that the corresponding angles that are congruent to each other will be H, angle H, and angle N, angle I, and angle O, angle J, and angle P, and angle K, and angle M. And I know all those to be true because H is the first letter in the first quadrilateral, and N is the first letter in the second quadrilateral. I is the second letter in the first quadrilateral. O is the first letter in the second is the second letter in the second quadrilateral, and so on and so on. So with that, I haven't even looked at the diagram yet, and I know that all of those angles are congruent because we know that the two quadrilaterals are similar to each other, and we know that those are the orders that they fall in. We can also write ratios for each of the sides. So the first side mentioned in the first part of the similarity statement is HI, and that will correspond with NO because that's the first side mentioned in the second part of the similarity statement. So we can make that into a ratio HI over NO. We can also say that IJ corresponds with OP because it's the second and third letter in the second and third letter of both parts of the statement. We also know that JK corresponds with PM. That's only 3, but now remember, we're going to take the first and the last and match it up with the first and the last here. So HK corresponds with NM. And let's look at the diagram to make sure that everything matches up the way that we expect it to. So if H is congruent to M, well, H here has a right angle marker and N also has a right angle marker. So that lines up. That makes sense to me. I is congruent to O. I has one line. O has one line. All right. So far, so good. J is congruent to P. J has 2 lines. P has 2 lines. Okay, that matches up. And then K is congruent to M. Okay, K is here and M is here. But that's not enough that just the angles are congruent. We also need to make the proportions of the sides. So HI corresponds with NO. IJ is going to be proportional to OP, and it corresponds with each other. JK corresponds with PM. That makes sense. And finally, HK corresponds with NM. So those are all the parts compared to the diagram. Remember, we didn't need to look at the diagram to make all those parts, but it is nice to have the diagram so we can check to make sure that everything looks right to us. Let's move on to writing our own similarity statement. And to do this, I generally look at the angles first and try to match up the angles that are congruent to each other. So the first triangle I'm going to write, I will just choose the larger triangle, VUT, and I will the order that you write the first triangle in isn't nearly as important as the order you write the second one in. So I will call it triangle VUT. And we know that these two triangles are similar because we have 3 angles that have corresponding congruent angles in between the two. And also the sides are proportional. VUT is twice as big. Every side is twice as big as QRS. So where VU is 8, its corresponding side QR is 4. That's twice as big. So that's proportional. UT is 6, RS is 3. Those correspond with each other, and UT is twice as big, so that's proportional. and the proportion is the scale factor is 2 to 1. And then VT is 12 and QS is 6. Well, 12 is twice as much as 6. So they all have the same, they're all bigger. They're all twice as big. All the side lengths are twice as big in VUT. So that's where the proportionality comes in. So now when we write our similarity statement, we need to make sure that the angles match up with each other. So angle V was the first one I wrote in the first part of my statement, and that matches up with angle Q because they both have one line in it. Angle U has 2 lines, and that matches up with angle R in my second statement. And angle T has 3 red lines in it, and that matches up with angle S in my smaller triangle. So now we have our similarity statement. VUT is similar to QRS. Now I'm going to go through and just make sure that all the side lengths are in their right place as well. So VU should be proportional to QR. Here's VU, it's 8, and QR is 4, half as much as 8. So those two sides do correspond with each other, and VU is twice as big as QR. And then we have UT, which is over here, that's 6, and RS, which is over here, that's 3. And UT is twice as big as RS, so they're proportional to each other, and the proportion is 2 to 1. And finally, VT, this one, should match up with QS, this one down here, and that matches up perfectly as well. It's the longest side in each of the triangles, and 12 over 6 will reduce to 2 over 1 as well. They'll all reduce to the same number, so they're similar to each other. So there you have a brief introduction on writing similarity statements. I think it's time you try it on your own.